Welcome to the deep dive. Look, you're probably here because you want to get a handle on complex topics and you want to do it fast, right?
Without getting totally lost in, all the jargon.
Exactly. Maybe you're prepping for a meeting or trying to wrap your head around a new field, or maybe you're just curious. We're here to help deliver those aha moments.
Without the overwhelm.
Right.
And today, we're tackling something pretty cool, actually. It's about how we can, talk to computers in just plain English and have them pull specific info from complex databases. It's called Text-to-SQL.
Text-to-SQL. Okay.
Basically bridging that gap between how we talk and how databases understand things. SQL,
Structured query language,
You got
right?
it.
So you don't need to be a coding whiz to get the data you need.
Precisely.
It's like unlocking this vault of data just by asking questions naturally.
That's a great way to put it.
And what we're really diving into today is some pretty innovative research. It's focused on making this whole process work better.
Especially using those big AI models, the LLM's large language models.
Yeah, looking at how they're getting smarter at generating and then picking the best SQL query for your question.
Prepare for some surprises, maybe. Some interesting findings in here.
Definitely. This is where you start to see the real potential kicking in.
And the implications are just massive. I mean, think about the sheer amount of data being created constantly.
It's exponential.
Totally. So being able to just ask a question in normal language and get a precise database answer, that's becoming, essential.
For what kind of things?
Oh, everything from automating business analytics, reports and insights, to powering the next wave of smart assistants and chatbots.
Making information truly accessible.
That's the goal.
And to show you how this is actually happening, we've got some really compelling research papers to look at.
Yeah, including work from places like Google Cloud, Stanford University.
Yeah.
Folks really pushing the envelope.
Okay, so let's get into it. The core problem, I guess, is that human language can be, messy, right? Ambiguous.
Oh, definitely. It's often open to interpretation.
Yeah.
But SQL, it has to be absolutely precise. No room for error.
And that's the central puzzle then.
That's it, exactly. How do you translate that possibly fuzzy human question into a perfectly structured, unambiguous SQL query? One that gets you exactly the data you intended.
Because just getting a query isn't enough.
Not at all.
Yeah.
LLMs have gotten amazing at generating syntactically correct SQL. It looks right.
Right.
But making sure it's semantically accurate, that it actually understands your intent and fetches the right information, that's still a major hurdle.
Ah, I see. So you could have perfectly written SQL code.
Yep.
That pulls totally the wrong data because it misunderstood what you meant.
Precisely. It's not just about grammar, it's about meaning.
Right. It's understanding the intent, how it maps to the database schema, the tables, the columns, how they link together.
All of that. And that's where this new approach called CHASE-SQL comes in.
CHASE-SQL. Okay, what's the story there?
Well, CHASE stands for Multi-Path Reasoning and Preference-Optimized Candidate Selection. Quite a mouthful.
Yeah. What does it do?
It tackles this ambiguity problem head-on. Instead of just generating one SQL query, it generates a variety of potential queries.
Okay. Multiple options.
Exactly. Multiple high-quality options.
Yeah.
The idea is, if you create several strong possibilities, you seriously increase the odds that at least one of them will perfectly match what the user actually wanted.
Huh. So it's like having a small team of SQL experts brainstorm different ways to answer your question.
Yeah, that's a good analogy.
And then you just have to pick the best one out of their suggestions.
That's the core idea.
Yeah.
And CHASE-SQL uses 3 distinct methods to generate these different candidate queries.
3 methods. Okay.
Yeah, aiming for both accuracy and, importantly, diversity in the options. Variety.
Makes sense. What's the first one?
The first is based on a pretty classic problem-solving technique, divide and conquer.
Ah, okay. Break it down.
Right. If you get at a complex question, the system tries to break it down into smaller, more manageable sub-questions.
Simpler pieces.
Yep. It generates SQL for each little piece, and then it figures out how to stitch those SQL pieces back together to form the final, complete query for the original complex question.
Okay, that's logical. Instead of tackling the whole beast at once, attack it piece by piece. What about the second strategy?
The second one is really quite clever, I think. It uses something called an execution plan-based chain of thought.
Execution plan-based chain of thought. Explain that.
Okay, so when a database gets a SQL query, before it actually runs it, it figures out the most efficient plan to retrieve that data, like which tables to scan first, how to join them, etc.
Right, the query plan. You can usually see it with an explain command or something.
Exactly. So CHASE-SQL leverages this idea. It guides the LLM to reason through the query construction process, almost as if it's thinking about how the database itself would execute the request.
Whoa. So the AI is learning to think like the database to write better code for the database.
That's the essence of it, yeah.
Yeah.
It helps the LLM anticipate the steps the database will take.
That sounds really useful, especially for complicated queries.
It is, particularly for questions that involve figuring out complex relationships between different tables, how to join them correctly, apply the right filters.
Okay, so we've got divide and conquer and think like a database. What's the third technique?
The third one is also pretty innovative. It's called online synthetic example generation.
Online synthetic example generation.
Meaning it means the system actually creates its own practice questions and the correct SQL answers for them.
It makes up its own homework.
Sort of. But it does this specifically tailored to the database it's currently working with. It generates examples that are relevant right now.
Why does it do that?
It helps the model get a much better feel for the specific structure of that particular database. The tables, the columns, the relationships, and how to query it effectively. It fine-tunes its understanding on the fly.
So it's like creating its own mini custom training data set just for this task right here, right now.
Exactly. Tailored, just-in-time training data.
Wow, that sounds really powerful.
It is. And the research showed that using these three methods, even just individually, resulted in significant bumps in accuracy compared to older techniques.
Any standouts?
The synthetic data generation, that third one, showed particularly strong results on its own.
Interesting. Okay, so CHASE-SQL uses these three methods, maybe all together, maybe separately, to generate a bunch of potential SQL queries.
Right. A pool of candidates.
So now you have this collection. How does it actually pick the best one, the winner?
Right. That's the second part of the name. Preference optimized candidate selection.
Okay.
CHASE-SQL uses a separate component, basically another trained model, that acts as a selection agent.
A selection agent, like a judge.
Pretty much.
Yeah.
Its job is to evaluate and rank all those candidate queries that were generated.
How does it rank them?
It does it by comparing them against each other, pairwise.
Pairwise. So it looks at query A and query B, decides which is better, then maybe A versus C, B versus C, and so on.
Exactly like that. The selection agent learns, through its training, to assign scores reflecting how likely each query is to be correct, given the original question and the database schema.
So it's making lots of little judgments.
Yep. Based on those pairwise comparisons, it figures out which query has the highest overall score, the highest probability of being the right one.
It's like a mini tournament for SQL queries. That's pretty neat.
It is. And the results looks good, right? It performed well.
Yeah, the experiments in the paper showed this selection process significantly outperformed a more common baseline method.
Which is usually self-consistency, I bet.
Exactly. Self-consistency, where you just generate a bunch of queries and pick whichever one pops up most often.
Right, the most frequent answer wins.
But CHASE-SQL is more nuanced, pairwise comparison approach.
The preference optimization.
And led to much higher execution accuracy.
Meaning the query it finally chose was far more likely to actually run correctly on the database and give the right answer.
Yeah, which is the ultimate goal, isn't it? Getting the right data.
Absolutely.
And here's something else I found really interesting. The researchers also looked at the sort of theoretical upper limit.
Like, how good could this be if the selection part was perfect?
Exactly. If you had an oracle that could always pick the single best query from the pool generated by those three methods, how accurate could you get?
And what did they find?
They found that by combining all three candidate generation methods, divide and conquer, execution plan, synthetic data, the potential accuracy, that upper bound was even higher.
So the pool of candidates generated by combining methods contained even better best answers.
Precisely. Which kind of suggests that the underlying LLMs, they might already know a lot of what's needed.
Right. The knowledge is kind of latent in there.
Yeah. It's more about developing better ways to surface that knowledge and, crucially, select the correct SQL formulation from the possibilities the LLM can generate.
That's a really key insight, I think. These massive models have absorbed so much information during training.
From the whole internet, basically.
Yeah. And approaches like CHASE-SQL are essentially building smarter mechanisms to tap into that vast existing knowledge base effectively for this specific tricky task.
So let's bring this back. What does all this mean for, for you, the listener, who just wants to get useful information out of data quickly?
Well, it means this text-to-SQL technology, it's getting Noticeably better, more reliable, more precise.
We're moving closer to that future where interacting with databases is just easier.
Yeah, much closer to being as straightforward as just asking a question in plain English and trusting the answer.
And techniques like CHASE-SQL, focusing on generating diverse good options and then picking the best one intelligently.
They're paving the way. They're making that future happen faster.
Okay, so progress is definitely being made. It sounds impressive, but it's not solved yet, right? What are the remaining hurdles? What's next?
That's a really important question because, yeah, despite these advancements, there are still significant challenges left.
Like what?
Well, human language is still inherently fuzzy sometimes, isn't it? And database designs themselves can be really intricate, complex, sometimes poorly documented even.
True. Garbage in, garbage out applies to schemas too.
Indeed. So these text-to-SQL systems need to get even better at understanding and resolving all sorts of ambiguities.
Both in the questions we ask.
And in the structure of the data itself. There are different types of ambiguity to handle.
And how do we even know if they are getting better? I mean, how do you properly measure performance here?
Evaluation is absolutely critical.
Yeah.
And it's tricky.
You mentioned execution accuracy earlier. Does the SQL run and give the right result?
Right. That's a primary metric. But it's not perfect.
Why not?
Well, sometimes, believe it or not, two different SQL queries can accidentally return the same correct result for a specific question on a specific database state.
Oh, right. So just checking the final output isn't always enough to know if the query itself was semantically correct.
Exactly. Might have gotten lucky. That's why researchers are also working hard on creating more rigorous evaluation methods.
Like better benchmarks.
Yeah, things like carefully designed test data sets, sometimes called distilled test suites, that are specifically built to differentiate between queries that are truly correct versus ones that just happen to work by chance.
So they can more accurately measure genuine understanding.
Precisely. Getting a more precise signal on how well these systems are really performing.
Okay, so it's this continuous cycle then. Improving the AI models and techniques. And at the same time, improving how we measure those improvements.
That's the process. It's iterative.
And looking ahead as AI keeps evolving at this, frankly, breakneck pace.
It really is fast.
These advancements in just understanding and querying data seem like they could, well, fundamentally change things.
I think so. Change how we interact with information day to day.
Professionally, obviously, but maybe personally too.
Absolutely. Imagine how much more easily we might be able to access complex information, analyze it, and just, make more informed decisions in all parts of our lives.
That really is a powerful thought to end on. How might this reshape decision-making everywhere?
Something to think about. And, if you are interested in digging deeper into this,
Yeah.
we definitely recommend checking out the actual research papers, the CHASE-SQL paper, for instance, and maybe look into the broader field of AI agents, natural language processing for databases. It's a super dynamic area.
Instantly changing.
For sure. What we've covered today, it's really just scratching the surface.
Well, this has been fascinating. Thanks for joining us for this deep dive.